Hi everyone, take a look at quiz 2. On the whole, pretty well done. Okay, a few lower scores, but on the whole, pretty well done. All right, so let's look at it. Now the first one, if you've been following along in the note packets, pretty much all this is in the notes. All right, I just changed the numbers. All right, so first one, now remember, whenever you do an equilibrium expression, products over reactants, that's our kind of general idea, right? So it's going to be this over these. But wait, right, only applies when it's aqueous or gas, because gases and aqueous can exert a pressure or a concentration, have a concentration, right? So the only one that's actually a gas or an aqueous is this one, right? So products over reactants, if this, we're going to cancel this one out if you like, because it's a solid, so it's 1 divided by, okay? You can have either one if you look at concentration or pressure, okay? Now, many of you just put like concentration CO2. Well, it's a reactant, not a product, right? So it's products over reactants. Here, they're all gases, so products over reactants, concentrations or pressures. Okay. Here, the only one that doesn't kind of work is that solid there. Products over reactants. There's 2H plus, so it's squared there. Okay. That was very similar to the other one, apart from I think I had tin instead. Okay, so it's very similar, but tin instead. Okay, so 2 versions of the test, forgot to mention that. Okay, so next one. Now this one, a couple of you like really overthought this, and you didn't. It was a simple, as seen in the notes example, right? Okay, so you're given a regular equilibrium, right? A regular equilibrium with a Kp. They're all gases, so it's Kp, right? You don't have to convert to Kc. Right, so products over reactants, there we go, right? Okay, you're given the equilibrium pressures, so there's no need to do an ICE table. They give you the final numbers, right? Okay, so it's just plug and chug, right? So products over reactants, that with the numbers inside is the value of K, right? Okay, so all we do is we're given the numbers, we have to find this one, and we also have K, right? So our destination is here, just do some algebra. There it is, right? So the thing we want, let's move things around, put the numbers in, 0.302 atmospheres, -1 for sig figs, -1 for unit. Okay, it's easier than you think, isn't it? All right. The other one, obviously I chose different pressures and a different final answer, 0.0953 atmospheres. Okay. All right. Now, this next one is taken directly from the notes. All right. So this is our first ever example of an ICE table. Okay. And it's, it's that 2, 1, 1 interesting stoichiometry where we can play that square root trick. Okay. So Kp, again, they're all gases, so Kp applies. There's no need to start converting to K, right? Kc. All right. So reactants turns to products. We have 0.5 as an initial, and it's 2, so you leave 2, we gain 1, we gain 1. That's our equilibrium kind of position in terms of algebra, right? Kp is products over reactants in terms of the algebra, there it is. And then you just kind of play some algebra tricks, move things around, and eventually solve for x. X, of course, is the concentration of N2 or the concentration of O2, same number, at equilibrium. 2.7 atmospheres for this particular example, right? I'll show you the other one in a second, okay? And then remember, 5.5 minus 2x is NO 0.1. Easy as that. Okay. Last one, Chatelier. Now this one is interesting. It says, you've got to read the question, right? Because it says, if it's assumed that the reaction is endothermic, so heat's a reactant, what conditions of external pressure, high or low, and reaction vessel temperature, high or low, will make more NO2, right? So if you think about it, I want to make the reaction move to the left. Now the easy one is pressure. There's 2 molecules here, 2 molecules here. It doesn't matter what I do with pressure. It's going to be unresponsive, right? Okay, so trick question, actually, no change with pressure. You got that, which I thought was good. Okay, now I almost caught myself out here, right? And so temperature, if you think about it, I want to make it go to the left, you know. And in our example in class, we always tried to make products, right? So it's kind of easy to make the mental error there that we actually want to make it go the other way, right? So if I want to go the other way, the reaction makes heat, yeah. So how do I make it make heat? Well, I cool it down because it does the opposite, right? So low temperature. Okay. On the other one, just real quick, same exact setup, but we've got 9.5. and then 4.6 for X, which is the pressures of the two individual gases, and 9.5 minus 2X, 0.3. Okay, 0.3 for NO. All right, and same answer at the bottom. Okay, hopefully that makes sense. Now again, try and look at this as soon as you can. Come to office hour on Thursday if you have questions, want to talk about your quiz. If you think I've, really horribly misgraded it, you're welcome to ask for a regrade, but it will cost 10% if you get the same or a lower score. And, I always do that, don't forget. All right, stop there. See you guys next time.